Hey guys, so it's Danny here again for information design. So this week we are going to be covering JavaScript and APIs. Last week we went over the basics of JavaScript and jQuery. This week we're going to take what we learned and mainly apply mostly jQuery to this lesson. So we're going to basically use an APIs, which stands for Application Programming Interfaces, to take live data from other third-party vendors like weather data, social media data, etc. So most of these third-party companies that have online products like Facebook and Twitter and Instagram, they all have APIs that allow us to basically pull live information from their databases, from their accounts. Which makes it a lot easier for us to build more dynamic, interesting products for the web. API stands for Application Programming Interface, which is just an interface for us to interact with an existing third-party application. So pretty much any company, any organization that has a web presence that collects data from their users is going to have some sort of API that allows either them internally to use the data in other ways, or for us externally to take that data and use it to build out other creative applications that they might not have thought of when they were initially building out their product. Basically how it works is you have a third-party application, third-party company like Google Maps or Facebook or Twitter. These are just a few examples, but there's tons of other ones out there. So basically how it works is we take information, we do a query, ask the third-party application, third-party company to send us their data in real time, and that data gets sent to our own website for use. You can also go the opposite direction, so you could also, let's say we wanted to post something to Facebook, to your Facebook account or your Twitter account from our website. You could push information from our website to Facebook or Twitter using the API as well. You could also delete information if you wanted to from a third-party website that uses the API. So for this to work, most of these APIs have an access key and sometimes have a secret key. Sometimes they have two different keys that you have to get created for you to use that particular API. So this is kind of like a key to get into your house. It's a key to get into that API, a key to get into their servers to get that information, to get that data. So we are going to be using API queries using URLs. So it's going to be something like www.apiswebsite.com / then a query, and then the access key that they provide us. So the query is just the question. It's basically asking what data we want to retrieve. So if we want to get weather data, for example, we can use the Open Weather Map API. And then usually when you see a question mark, that means it's going to be a query. It's asking a question. For this query, we're asking to get the current weather in London, and we're using an ampersand to add on more parameters. And then this is our API key that gives us access to the Open Weather Map API. So we have the key, and then we have our query. So we should get in return the answer, which would be the current weather in London. Pretty much all APIs have documentation associated to them, which allows you to understand how their data structure works, how their API actually works, and what information you can retrieve from their API and how to query that information. So this is one example for Open Weather Map. We're going to be playing around with this one later today when we do the demo. And it basically allows us to better understand how the API works, the type of data that we can query, whether that's a JSON or XML or HTML data. It also allows us to understand how we could ask for that data. So you could ask by city name, it looks like, by city ID, geographic coordinates, so latitude and longitude points. You could also ask by zip code, etc., etc. So this is just a small portion of the documentation, but there's tons more. For any API, you're going to want to look at the documentation before you actually start programming, so you know how to write your code and what to ask when you're making a query to that API. So other ways of using APIs is for user authentication. So if you're building a more robust website that has a user login, you can use an API to, rather than creating like an email and password login, you can use APIs to use their logins for like Facebook or Twitter or Google to log into your own site. So that's another use case when it comes to working with APIs for these third-party platforms. Another good example is Google Maps API. Google Maps is used by lots of other applications, lots of other third-party products and platforms. There's other options too. There's Mapbox, which we'll talk about later today, and actually be creating a Mapbox map for our own websites. But Google Maps is probably the more robust one and is used by most of the web apps or mobile apps that use any sort of mapping or directional information. So one example is Google Maps is used in the Uber app and Lyft apps. So any of the car sharing apps, for the most part, are using Google Maps for their own map and to display where all of their cars are and where you are. So another interesting thing that I see a lot is using multiple APIs and kind of mashing them together to create something new. So another example is using, looking at Uber again. Uber, I believe this is still alive, Uber uses the Spotify API for you to basically play your own playlists on Spotify in the Uber ride that you would be taking. So Uber uses the Spotify API, the Google Maps API, and I'm sure they use plenty of other ones to create the platform that they need that's much more robust. Here's another example that United Airlines app is using the Uber API. So Uber has their own API as well. So United is using the Uber API that is basically connected to your United app. And it can detect when you're landing in a certain city and can call you an Uber automatically because the United app knows when you're landing, where you're landing, and when you will be ready to take a car. This is one example that was created by Kyle McDonald. Unfortunately isn't live anymore. It's using the Spotify API and D3.js to create a map that is displaying whenever two people play the same song at the exact same time on Spotify. It's displaying where those two people are and the name of the song that they're listening to. Here's another really interesting project that is created by Lev Manovich, and it's using Instagram's API and Amazon Mechanical Turk to basically pull in and analyze tens of thousands of selfies on Instagram, and basically creating this interesting filtration application that allows you to look at where these selfies were taken. It allows you to filter by age, so you can look at young versus old people taking selfies. You can look at gender. You can filter by position, head position, head tilt from left to right, eyes, whether they're wearing glasses or not, if their mouth is open or closed, and then also if they're calm, angry, or happy. So all the images are obviously taken from Instagram using their API. And then Amazon Mechanical Turk is basically a service that allows anyone to create a task for someone else to do. And it could be something like very small, like look at this picture and tell me if they're wearing glasses or not. So that is how all this data is put together, is basically a bunch of people looked at these images and then categorized them by if they had eyes open or closed, if their mouth was open or closed. So this is a really interesting project as well. This is a great project called Tunnel Vision. It's an app, an augmented reality app that unfortunately doesn't work with the latest version of iOS, but it is a combination of MTA data and this augmented reality application called Vuforia. And there's also a bit of census data that is being pulled in as well. So there's a little video that I'll play. So when you hold the phone up to the MTA map in New York City, it'll show you an overlay of where all the trains are. And then there's also more information that you could look at census data. So how much the median income is at a particular subway location. There's also information on turnstile data that you can get from the MTA, which is pretty great. So it's a pretty great app that uses an SDK that's for a Vuforia SDK for the augmented reality aspect, and then they're pulling MTA data using their API. So it's a really great combination of multiple APIs and multiple SDKs. So another good example is this project that uses the Foursquare API and a Raspberry Pi, which is like a little computer that's connected to the internet, that basically allows you to check into a location. And when you check into that location, it'll dispense a little gumball from this gumball machine. So this is a good example of how you can use a digital app and use an API in that app, and then have that work with a physical object that is sitting there. So basically this is, let's see if I could play the video real quick. So how it works is when you check in to a location, then it can detect that you checked in and then dispense a physical object, in this case a gumball. And here's another kind of example that's in that same realm. It's playing around with the digital and physical environments. So SciFi used a combination of their app and audio recognition and collaboration with the Philips Hue light bulbs API. So those are the Wi-Fi enabled light bulbs that you can get. And there's an API for those as well. So you can create your own app, create your own website to control the lighting in your room. This is just an interesting application where it's basically detecting audio while you're watching, in this case, Sharknado. And then during specific parts of the movie, it'll detect what's going on and flash like your lights in your room red or something like that.
We've added this functionality to SciFi Sync for iPhone and iPad. And once you actually start watching an episode that's sync enabled, it'll automatically listen to the audio and you'll start to get your light show along with all the content that you get through the Sync app. Once you have it set up on your device, you can actually sync it to the Philips lights in your home. You can set up which lights you want to be affected by the sync experience. So right now we're doing it for Sharknado and Sharknado 2, and really looking at sort of what we can do to sort of punctuate scenes, try to not pull you completely out of it, but it's Sharknado. So we can go a little more over the top than we would with, with a drama or something a little more serious.
So basically when a shark attacks, then your lights can turn red in your room, which is pretty great. Here are a few projects that I've worked on that use APIs in different ways. So this is a website that allows you to type in your current location, and based off of that, I can pull in your weather for the next couple of days, and then I'm mashing it up with a fashion API. So basically when it's warm, I'm going to suggest that you wear a t-shirt. If it's cold, then I'm going to suggest you wear a sweater or a hoodie or a jacket. So this is very limited code. It took me less than like 2 hours to put together because I'm getting data from 2 different places. I'm not putting together the data sets myself. I'm just pulling information from a weather API and then pulling information from a fashion API and mashing those two together. Here's a project that I recently did for an organization called Color of Change. It's called vote.colorofchange.org. And it's basically taking the Google API, Google Contacts API. So you sign into your Google account. We pull all your contacts from your Google Contacts account, and then we compare that to the voter file. So basically we could determine out of all your contacts, out of all your friends, we can determine who is registered to vote and who is likely not registered to vote. Based off of that information, we encourage you to get them registered to vote. Here's another project that is related to voter information, again for Color of Change. It's called Remix for Change that we did in collaboration with glitch.com. And basically it's just a voter information web app that queries a few APIs and allows you to search for who your local representatives are, and it pulls up information around the last 100 state bills that were passed in your particular state, based off of certain filters like bail reform and police and prison and discrimination. So that's an interesting project that we encourage people to take the code and kind of remix it and make it their own. So those are just a couple projects and examples of how to use APIs. APIs have been around for quite a while, but they've been picking up steam over the years. Today, pretty much any company, any organization that has an online presence has some sort of API associated to it. And you could also find some really interesting, really unique APIs out there. Like there's APIs on breweries in the United States. There's APIs on like the best pizza places. There's all sorts of APIs out there. So if you wanted to find something more unique, more interesting, then I would just do a quick online search by saying like pizza APIs or cat APIs or dog APIs, just kind of see what's out there and see what's available. So there is another platform that kind of makes connecting all these APIs a little bit more user-friendly. It's called If This Then That, or IFTTT. And it's just a service that allows you to like easily select Google Mail and connect it to your Philips Hue API. So when you get a email, maybe from a specific person, then your Philips Hue lights in your apartment can blink on and off. So this just makes it a lot easier to do like drag and drop the API connections. So it's kind of a fun platform to play around with and explore with. So when it comes to the data that you get from most of these APIs, usually it's in this format. It's called a JSON Data format. Stands for JavaScript Object Notation. And it's different than your traditional like CSV file or TSV file, which is tabular. This is based off of nesting, essentially. So this is an example of the API for City Bike in New York City. So we have a object called station bean list. And then in that object, we have an array of stations. And each station has an ID, a station name, and available docs, total docs, the latitude and longitude, etc., etc. So this is the type of data that you're going to find initially, for the most part, when it comes to working with APIs. And we'll talk about how to actually go into this data and pull out specific data points when we do the demo later. When it comes to making a query to an API using JavaScript and jQuery, we're going to be using jQuery just because it makes it a lot easier to make these queries and pull this data. With jQuery, there's a AJAX method that is created for doing asynchronous requests. Basically, this allows us to do a query to a URL, there is a type that's, in our case, it's going to be a get type. So we're going to get information. You could do a data type. There's multiple data types. Then this is the data. It's the data that is sent to the server. Once you get a response, then you have a success function here, and you can pass in the data that you are getting in response. And then you could also have an error function here just as a backup in case anything goes wrong. So this is a little more complicated than what we need. So we are just going to be using this method, this function that comes with jQuery instead. It's the GetJSON method. So basically it just allows you to use this method and then pass in the URL with the query and your API key in it, and then run a function and then pass the data that you're getting back from that response. And then in this function, you can use that data however you like, whether it's pushing it to the document, your HTML document, to display it on the screen, or running an alert function or something like that. That's up to you. So one other issue that might pop up is if you are running this locally on your machine and just trying to open it up in the browser from like an HTML document just by double clicking on it or something like that, then you're probably going to run into this issue. And just for good measure, it's always good while you're programming in JavaScript to have the JavaScript console open. This will display any sort of error messages to you in red. So this will help you debug your code if for some reason it's not working. So this is one thing that'll pop up if you're running this locally. For this class, we're going to be working in glitch.com, so this shouldn't be a problem for us. But if you are running this locally, you'll get this XML HTTP request error. That basically just means you're not running this in the server. So you have to run this when you're loading in or doing a request to an API. Not always, but usually you're going to get this message. If you're loading in data, this will definitely pop up. Better to run a server locally if you're doing this locally on your machine, or just use a platform like glitch.com, which is running on a server anyway. It's already online and web-based, so you won't have this problem. But again, it's just always good to have the JavaScript console open to check to see if there's any errors popping up to help you debug. So for the demo, we are going to be playing around with 3 different APIs today. So we're going to be using the Open Weather Map API to pull live weather data and display that on our own websites. We're going to be using the Mapbox API to display map data and geographic data on our own websites. And the last one we're going to play around with is the Jiffy API. So Jiffy allows us to pull in animated GIFs using keywords to display on our own website. So we're going to be using these mostly separately, but obviously you can use multiple APIs together. So you could put all of these together on one website that you're building if you wanted to. So I'm going to do the demo in a separate video, so feel free to check that out next.